This video is brought to you by the Logitech Lightspeed Wireless range of keyboards, mice and headsets, the benchmark in wireless gaming performance.
Hello and welcome to another interview special here on Digital Foundry. This time, not too long after the release of the game, we're here with Panic Button and id Software to talk about that Doom Eternal conversion to the Switch, and basically all things Switch, because it's such an interesting topic, and I'm so happy to finally have a chance to do this. So first I'm joined by Travis Archer from Panic Button.
Hello, good to see you.
Good to see you as well. And once again, I am joined by Billy Kahn from id Software. Billy?
Hey guys. It's awesome to have me here. Thanks for having me. I appreciate it.
Yeah, no, it's good to have you guys here. Says, yeah, I mean, a lot's changed since we last discussed anything regarding Doom Eternal, obviously. The game's out, the DLC's out, the first one, the Switch version is out. Everything is a known quantity. So first of all, I already did a video on Doom Eternal for Switch, and it was very well done. So, as usual. So first of all, good job.
Thank you. Thank you.
Thank you.
So next up then, obviously, you know, when we looked at the original, it's clear that id Tech 7 had evolved in numerous ways. The levels were bigger. You were doing all kinds of stuff. You know, the mega texture system was ripped out and replaced. You had all the stamping stuff in there. You know, everything was pushed out to the limit, and yet it looked and ran better than ever. So it was really, really good on those consoles. And then it comes to Switch, and weirdly enough, in many ways, I mean, maybe not weirdly, we're going to find out, it was actually perhaps one of the smoothest and clearest of these ports yet, despite the game sort of pushing the technical envelope. I kind of want to get into basically how some of this was achieved. So obviously, let's just start with the basics. So you finished Doom 2016, the Wolfenstein games reported to the Switch, Doom Eternal's coming up. What's going on with you guys on the back end to prepare to bring this game over to the Switch?
Well, sure. A lot of it is integrating id Tech 7 to the Switch, just getting the basic functionality working correctly, and that's a long and involved process. And then but before that, we had obviously worked with id Tech and worked with id and Billy's team for a long time, and so we had that going on. And so when we started working on this process early on, we went down to their office and talked to them at length about how we were going to do the Switch port, and we had the opportunity to collaborate and come up with some ways to make the conversion to the Switch easier. I'll just give you a quick example. We were able to collaborate on how the light maps get generated to make sure that they would work well on the Switch, and work better. In fact, they were half the size they were on previous iterations of the titles due to that collaboration. So it was critical to fitting in memory. Just one example of the many things that we collaborated on. And yeah, it was great to go down there early and be involved in the process and get to see the game at an early stage. And you could tell when we first saw it, we could tell this was going to be a game that was exciting and fun to play, and in every way, a cooler, more awesome version of Doom in 2016. So we've been excited to get this game out the door ever since that day.
Yeah. So I mean, as you know, John, I've talked about this before. Our mission statement when we talk about id Tech in general is we want customers and players to wonder how we were able to run at such high frame rates and with the visuals and the gameplay that we have. That's always our mantra. So id Tech 7, one of the things that we had planned for that and what we really strive for is scalability. That included making sure that all of the work that we are doing on the CPU and the GPU could be parallelized, and it could be ramped up and moved around and within the frame easily, so that all fits. Obviously to run on the Switch is a vastly different thing than running on the last gen consoles that we had, or in the PC even. So, but that was all considered, throughout the development process. We knew that we have to run on whole variety of different hardware, maybe on PC, but also on embedded platforms like consoles. The goal there was to how can we do that? And so we built that. We focused on that quite early on, and I think by us running so fast on all the other platforms was also helping it. So when we were getting to the Switch, we could scale much easier, and we like new CPU performance. I mean, we have less cores on the Switch than we do on the the last gen consoles, or even in some cases on the PC. So that was a big task, and I think that worked really well on scheduling those tasks and jobs. Memory, as Travis already pointed out, was a big thing that we had to consider. But if you look at it holistically, one of the big key factors was making pragmatic choices for the platform, so it still retained the gameplay that we want to keep, and the visuals as best as we can. The core idea is you want to be able to play Doom in a portable fashion. Switch is really awesome about being able to play it portable. So and Doom's history is about playing it everywhere. And so pragmatically, you wanted to make sure that same core gameplay experience was retained, while making pragmatic choices on the visual side, so we can retain that awesome, high intense, action packed FPS experience.
Just to riff on what he was saying, the scalability was a critical factor. This game could not have been ported to Switch if id Tech 7 wasn't incredibly scalable. That was a necessary starting point. So even though the job of getting it to the point where we did at ship was a big challenge, it wouldn't have been possible if the engine wasn't so scalable. So there are games that are easy to port and there are games that are hard to port, generally speaking, and sometimes the engine is the reason it's hard to port, not the quality of the visuals or anything else. Sometimes the engine is inflexible or is just so inefficient that the effort involved in making it run efficiently enough to fit on the Switch is out of scope. It would be a complete engine refactor. And so this is a case where this incredibly high visual bar and the gameplay intensity that they put into Doom Eternal would not have been possible on the Switch without the effort they put in to make this engine so scalable. So that was the starting point. And then from there, it was the challenge of, okay, how do we make this engine, maximize, utilize the Switch's unique hardware capabilities? And that was the process from there.
So that's interesting then. So I guess at the first part, is this still using Vulkan on the Switch, or is it using the low-level Nvidia API?
Yeah, we do not use Vulkan, and we get asked that question a lot. We haven't actually used Vulkan on any of our titles.
That's what I thought, but I couldn't remember because I know it seemed like id Tech 7 was really pushing towards everything Vulkan. So I wasn't sure if that changed, but it sounds like you've not switched that at all.
We use Vulkan pretty much anywhere on the PC platform. For every platform that we ship on, we try to use the lowest level API that is available on that platform. Okay. Right. So, but the notion of our tooling, like its Studio and things of that nature, are all using Vulkan because of its our ability to be able to collaborate with the IHVs. To not only work on the current title we're working on, but also to be able to get new features into the APIs that we can then exploit in our titles down the road.
Okay,
so a lot of R&D goes in that as well.
So this kind of gets me to where that was going. So it's not Vulkan, obviously, but I guess the other consoles that the game is originally optimized for, it's all AMD hardware, whereas the Switch is Nvidia hardware. Can you talk about what kind of impact did that have on development? What was the approach necessary to sort of like how did that differ, basically, the AMD versus Nvidia thing?
So that's one of the core things that we have to address during our development process. And as games have become more and more optimized for this previous gen, PS1, PS4, Xbox One, and now of course this next gen, there's a move in a new direction, a kind of a paradigm shift towards random access memory use versus pipelined memory. So traditionally, you want all the data that the GPU is going to need to be loaded on the GPU before it tries to do anything, so that there's no memory stalls. Mm-hmm. And that's necessary because of how slow memory bandwidth used to be and how little GPU cache there was to work with. It was critical that data be there in time. For Xbox One and PS4, and again, obviously even more so with PC, there's so much memory bandwidth and a larger GPU cache that it really opens the door to a different approach to programming. and a much more flexible approach, and it allows you to solve other problems that wouldn't be possible to solve without that. So we have to kind of go in a different direction. For the switch, we have to really just pipeline everything we possibly can. So instead of data being accessed during execution from a large buffer, we might have to preload all that data into a small buffer before we begin execution. And so there's a lot of work that goes into manipulating the data, packing it, rearranging it, and getting it to work in that way. That's one of the biggest challenges of porting to the switch.
Oh, that's interesting. So a lot of data manipulation there on the switch side of things.
For all the platforms that we work on, it's not like we develop just for one type of architecture.
No, of course.
On the PC,
of course.
On the PC, we do exploit all the things that the hardware that it provides. It doesn't matter what the GPU is. That's always been our path forward, because we want to bring the best experience to anyone, to allow the titles that we make to be played in the best experience for any player that's out there, no matter what the hardware is. The goal is to allow people to play Doom whatever they have, at the best quality they can have. So we would work really hard on making them shine on every piece of hardware that's available. It may be a GPU on the PC, it may be a console, and the Switch is no different there. One of the things that Travis is actually alluding to is our bindless model, where we have which we started that process in 2016, and that was a forward-thinking thing that we wanted to do because of the things that we now are getting in hardware, of ray tracing and so on. A bindless model basically means you bind to all the resources in these gigantic buffers, and then you can access them from anywhere on the GPU because you know where they're located in memory. And that opens up a lot of things that you can solve a lot of problems with that. It does make some older GPUs or older it makes some things a little bit more difficult on certain pieces of hardware, and the Switch was one in those categories. Because we pushed on the forward-thinking motion, we had to do some refactoring to make that work on the Switch, which is fine. It's just a little bit more work, and we're familiar with how that needs to be done. But it was, if you think about ETEC 7 is more like a next-gen engine running on last-gen hardware, if you think about it that way. So
very much so.
and that's great, because now we're ready to go for what's coming next. The Switch was a really fun project, because it kind of validated the direction we're going. We were able to scale, forward and backwards, and with not too much effort. I mean, Travis's team and Panic Button are wizard when it comes to making these kind of changes, and the collaboration with them was amazing. So we were able to achieve something that that couldn't be done had we not collaborated early on together.
Do you do any kind of feasibility study on specifically the types of things that need to be cut? Because obviously the bindless model on the other consoles and the PC doesn't translate directly over to the Switch, you're basically saying here. So how do you determine, all right, where are these bottlenecks that you're going to have to deal with, and how are you going to translate that over? Obviously you have fewer CPU cores in the Switch, right? So you have to handle that. You have less memory to deal with, so obviously the textures took a hit, but obviously all of this stuff needs to be figured out pretty early on and then actually executed from there. Can you talk a little bit about that process, how you determine what you were going to cut, how you were going to cut it, at what point in the process this stuff kind of happened and was decided, that kind of thing? I'm really curious about that.
So early on in the development of Doom Eternal, we had the advantage of having shipped multiple titles with IDTech 6 and 6.5, and so even though IDTech 7 is a huge generational, version increment, there were still some core features that we knew were going to be present that we could, and going down to talk to them, we got a chance to look at their rendering roadmap and have a sense of what we were preparing for. But the lessons learned from those previous titles was very critical. So in the case of Doom 2016 and Wolfenstein 2, the triangles that we were throwing at the screen was absolutely our bottleneck. I think our worst case scene in Wolfenstein 2, we had about, I want to say, 5 million triangles being processed on screen, and this is post CPU culling. So we cull out Wolfenstein 2 had maybe 30 million triangles in the worst case, and you cull that down to 5 million on the CPU, and then on the GPU you have to cull that down. Well, we're culling down from 5 million to 200,000 on the GPU, so that the triangles that we actually pay expensive rendering for, we're only paying for the ones that are actually going to hit the screen. And so we knew that was going to be a challenge with this title as well, but in actuality, it was less of a bottleneck than on previous titles, because one of the big improvements between Doom 2016 and Doom Eternal was the implementation, moving away from megatextures, as Billy pointed out, towards individual meshes with mesh level of detail. You can have more detailed triangles on screen with fewer triangles overall. So you pay your triangle budget so that the detailed ones are close to the camera, and the less detailed ones are far away enough that you can't tell the difference. And that meant that we were getting better triangle density for the same amount of total triangles, and instead of wasting high detail triangles way off in the distance. So that was a huge improvement. And in fact, we pushed fewer triangles in Doom Eternal than we did in Doom 2016, but the overall result is more detailed, significantly more detailed, both in terms of the character models and the backgrounds. So that wasn't a case where we knew we had to plan for it anyway. Despite all that, it's still our bottleneck, even despite that improvement. And so we have technology that we put in place all the way back in Doom 2016 that we continue to use today, which is the way we cull triangles on the GPU, which is different from the other platforms. It's another example of how we do things a little bit differently on the Switch. The other platforms take advantage of async compute to do triangle culling through compute, and that's not efficient on the Switch. So what we do instead is we actually do it during the draw pipeline in a geometry shader, which is something that also would not be efficient on those other platforms. So It's a different way of approaching it, but the same outcome.
That's really interesting. I was actually going to ask about that because, the Switch architecture, I think that's Maxwell from Nvidia, so it wouldn't have had really async compute as an option necessarily, right? So that's interesting to see how you actually tackled that problem.
Yeah, it's surprising how well it works. To be able to cull 30 million triangles a frame at even 30 hertz on a battery-powered device is impressive. I think so. But yeah, for that and other things like that, we rely heavily on taking advantage of what that architecture can do well. And in some ways, even though it's a low-power device, the Switch is actually in some ways more advanced than the base PS4 and Xbox One. If you think about when those base consoles came out, that was about 4 years before the Switch came out, and there were GPU technology advances in that time. Some of them made it into the Switch, and so we have, it's kind of a strange hybrid, where we can do things that kind of make up for the low power nature of the device.
That's really there's some techniques that we can do on the Switch that really benefited us to make that run. I think the micro triangles were a big thing, culling those micro triangles so they don't, you don't overshade those things that are really far away. We also added things, on the content side, we added different LOD levels so we can have more fine-grained LOD selection. One of the things that was really important for us was to retain a lot of, geom caches were a big thing in Doom Eternal. A lot of the highlight moments that when you play the game are geom caches. So making those run, we knew we had to do something to make those run well. So there were discussions that we knew where we needed to, allocate what we want to spend the budget on. And it's almost like, a spreadsheet where you're like, okay, I have $100 to spend, what do I want to spend it? And that early involvement really helped with that. On the content side, knowing where the bottlenecks might be, because we have, as we have millions of triangles being slammed through the hardware here, and doing it on a Switch required us to just tone that down for the resolution we're rendering it, and making sure that that was done in a way where the user may the impact on the gameplay was the least detrimental there. We wanted to make sure that the feeling was retained, and I think we were able to accomplish that.
I guess that ties into one thing that is missing from this version that I was curious to hear your reasoning for it. id Tech has been really big on lots of heavy post-processing effects like bokeh depth of field, per object motion blur. and I love those effects. And those were in the Doom and Wolfenstein ports on Switch, but it was absent from Doom Eternal. And I'm wondering what part of the rendering pipeline made you say, okay, we got to cut these effects to get our performance up or memory budget up, or what was the reasoning behind removing that?
Well, and in some ways, this is our general philosophy when we approach a rendering feature. We look at it from the overall impact. So if we cut this feature, what is the overall visual quality impact versus keeping it? And the cost in the case of motion blur of keeping it is reduced resolution. And the reduced resolution overall has a bigger quality impact to where, and not just that, but also frame rate impact, because there are scenes where it would not have held 30 if we kept motion blur in. So this is something that obviously is a hot topic among gamers. Some people love motion blur, some people don't. And we would love to be able to put that back in if we can scrape together some more optimizations over time, and make it to where we can maintain that quality, because it's really critical that the gameplay be smooth in Doom Eternal. It's the most important thing that we maintain that frame rate. So, but that's generally the philosophy we take with all of our features that we look at cutting. What's the net impact? Is it a better game with it or without it? And for the Switch, a lot of that comes down to resolution.
That's really interesting, because that is that kind of explains why Doom Eternal does seem to maintain a higher average resolution than the Wolfenstein ports. Those could drop pretty darn low, and many of the battles were often well under 30 frames per second, whereas Doom Eternal is much more consistent, and it really holds that frame rate, and the resolution is higher. So that's obviously one of the key reasons I guess it's improved. Can you talk about what else has allowed you to hit this steadier frame rate in a more complex game?
When we make those choices, we try to look at the image quality overall, and what we saw at the resolutions we're running, that the motion blur did not have the impact that we wanted it to have. And so we made the pragmatic choice of saying fluidity of gameplay and higher resolution overall was giving the consumer and the player the better bang for buck. And also, I would say that the changes we made in Tech 7 were one of the mostly the contributing factors to allow us to achieve the higher frame rates. There were some bottlenecks that we had in Tech 6 and Tech 6.5 when it comes to vertex processing, and it was coming to parallelizing our CPU workload that Tech 6 fixed. And a lot of that was even regardless if you would have removed or turned off motion blur in that case, for example, we may not have reached the same speed, because of the So I would say the architectural changes we made on the engine side, including all the pragmatic choices to make this run well on the hardware, allowed us to achieve the higher frame rate. So sometimes unfortunately it's not as simple like, I'm going to turn this off, I'll get massive.
Oh yeah, I wouldn't have expected it to be, honestly.
Right.
But
There are so I would say I think it's usually a lot of things working together in a cohesive unit. The disabling motion blur in this aspect was just one piece of the puzzle. There are a lot of other pieces that had to fall in place to make this work out, and the collaboration and working on the tech together early on, as well as the Tech 7 changes, allowed us to do that.
And if I may, I'd like to point out that Billy's team is also a big part of the reason that the game does run as smoothly as it does on Doom Eternal. They were able to help us at the end of the project to come in and directly help us kill some of the worst performing scenes, or rather not kill, but improve the frame rate in some of our worst performing scenes. So we really took the time to target those worst scenes on Doom Eternal. That was a point of emphasis to make sure that every combat ran smooth. And so, their obviously vast experience and knowledge of their own engine was critical to that. It allowed us to make changes to the content, subtle changes that you would never notice that improved performance significantly, and their familiarity with the tools and how their content was set up, and their own code obviously was critical to that. So I just want to call out Billy on that and his team for being. They've just been great to work with in general. I mean, going back all the way to 2016, it's been a pleasure to work with them and their team. They're really experienced industry veterans who know what they're doing. Like, they're some of the best in the industry. There's no other way to say it. So I just want to give a big shout out to them for their
Yeah.
contribution to this.
Thanks, Travis. I mean, it's been awesome working with Panic Button. Panic Buttons are magicians when it comes to, making these impossible things happen. I think we learned our collaboration. We learned quite a bit from each other. Approaches, techniques, workflows. And I think that was a really awesome experience, and it was a really fun project, right? Because we were shipped Doom Eternal, and I was like, oh, we need to know. We also have Switch to do. Let's do that as well. And we were able to come together and crank it out, and here we are. And I think one of the things is I think both of our teams really want to provide the best product we can produce. And we want to make sure that it really it's not just thrown over the fence or here's the thing. We wanted to make it really shine. And I think, your evaluation of the game really made us happy, because I feel like we accomplished what we were set out.
I think you guys did, absolutely. And, I guess one of the things that it seems to me, based on what you're saying, is that it's just the power of collaboration. Because, I guess when Doom 2016 was ported to Switch, I gather that was not the intention originally, because the Switch, it didn't yet exist, and obviously it was sort of like we're going to try to bring this game to the Switch after the fact, whereas with this, obviously, you guys were working together from the very beginning to ensure that the transition would be smoother, and it was, so that's good. We're at an interesting point now, because the next generation has begun, and, What do you see as far as continuing with this sort of work on the Switch specifically? Because do you think you could still see a PS5 class game being brought over to the Switch using the techniques that you've employed currently, basically?
I think one of the challenges there, you see this with Doom Eternal, we're really pushing the limits of how far can you go? You take textures and meshes that were designed to be, to look great at 4K resolution, and we're talking very, very small micro details in both the textures and the meshes, and you can only compress those down so far before you lose the original art direction and the original look and feel of the game, and you can have entire geometry features just disappear and turn into a flat plane. And so at some point there's kind of a limit, I think. And if you took a game that was designed to maximize what the PS5 can do, I think the end result would not necessarily be something that would be great. It just depends, because keep in mind, when the PS4 first came out, games weren't perfectly optimized for the PS4, and so it's going to be the same thing this time around. The big difference in my take on this is that if companies really lean in towards ray tracing, that is going to complicate things for the Switch, obviously too. But also as a company, Panic Button, when PS4 came out, we started working on PS4 games. When the Xbox One came out, we started working on Xbox One games. When the Switch came out, we started working on Switch games. And so, from our perspective, it's just, there's still a lot of demand for Switch titles, and there's a big backlog of titles still out there that people would love to see come to the Switch. So I have no doubt that we'll continue to do that kind of work, but we'll also probably be doing some more now current gen work as well.
Cool. Another thing I was thinking about changes on the Switch, and I'm wondering if you can explain in more detail. So on the Switch version of Eternal, the cutscene playback in portable mode specifically, everything runs at 20 frames per second instead of 30. And I also noticed that, the cutscenes in general were letterboxed, which was kind of a shift from the prior games. Can you talk about why that decision was made?
Well, yeah, sure. As is typical with most games, the cutscenes are sometimes the most graphically intensive scenes in the game. Lots of dynamic lights, lots of shadows, lots of animated, complex geometry on screen. And so, in this case, the importance to us was not losing that detail for the cutscene, because it's kind of it's a big payoff moment that that's supposed to look really cool, and we decided that it was better to run at higher resolution in this case, since it doesn't affect the gameplay. It's not impacting your ability to fluidly move around the game. When you're in the middle of a cutscene, it was less critical Now, in terms of the end result, I think there are still improvements we can make towards those cutscenes, and we do intend to make some improvements to the cutscenes to improve the performance of those. But that was the decision mostly made based on just how high the quality bar is for those scenes.
What about the how much of a performance saving, roughly, would you say like letterboxing the scenes would have? I mean, does that really save a significant amount of GPU power there, or?
It does. It actually does. I mean, the way we handle it, it's essentially whatever percentage of the screen we're not rendering to, that has a nearly linear impact on the frame rate.
Cool.
So, and in the case of the 20 hertz cutscenes specifically, there is a nonlinear improvement to performance, or not nonlinear, but rather it's not one-to-one. So, for example, the whole issue is that dynamic resolution scaling is not, it does not scale 100% perfectly. So if you run the game at half resolution, it doesn't run twice as fast. So because of that, small improvements to the amount of GPU time you have available have large impacts on the resolution, and it's almost a factor of 2. So, if you double the amount of time you have to spend to process the frame, you can render 4 times as many pixels, not just twice as many. So there's an outsized significant improvement to the resolution from that. And in the case of, generally speaking, if a game is running at 25 FPS, unless you have a device that supports variable resolution, or variable refresh rates rather, it's going to be choppy and have judder at this inconsistent 25 FPS. And so a solid 20 FPS will not look significantly worse in terms of frame rate than an uneven 25 FPS, generally speaking. It varies depending on the hardware, obviously.
I tend to agree, especially for cutscenes, where it's better to have that sort of even motion as opposed to sort of the uneven judder you get from 25. And that actually makes me think of one of the other kind of big improvements with Eternal is it finally mostly killed the frame pacing issues. So this is something I brought up with the prior ports. It was especially noticeable in Doom 2016. I mean, you know what I'm talking about, where it's like, you have a frame present, for 30 frames per second, you should have a new frame and then a duplicate frame, 33 milliseconds total, and it should always be this exact cadence. But in those cases, in those other ports, you'd often have, you'd have a 16 millisecond, and then you'd have a 50 millisecond frame, and then like a 33. So you kind of get a little bit of judder in the motion. And Doom Eternal pretty much solved that for the most part. What did you guys do to actually kind of conquer that issue?
Well, so in Doom 2016 in particular, there were a few things that made that worse and more noticeable. One of which is that we didn't use the adaptive tick system the same way the other versions of Doom 2016 did, and that was because of there were some real challenges with the physics system running at very low frame rate. That ultimately we have to process the simulation no slower than a certain amount. So if we have a frame that takes 100 milliseconds, we can't have a 10 FPS physics frame. It starts to create issues with the simulation. One of the most obvious examples is you might fall through a platform, or a collision hit might not be detected, causing you to not get credit for shooting something. Lots of things of those nature start to happen if your simulation isn't running fast enough. So one of the things that once you hit that minimum bar, you kind of have to slow down the simulation to compensate. And that also contributes to the feel of poor frame pacing. Is that there's essentially the game is running in slow motion when you have really slow frames.
Yeah, and what accentuates that is the lower the frame rate, the more any kind of error accumulates. Like it makes a big difference. Mm-hmm. And we use it like Travis mentioned, we're using an adaptive tick system where we can fluctuate between frames. If you can jump from, from 144 hertz down to 120 to 100 and back up to 144 hertz, and the user on the PC should not be able to use that because our lowest bar is 60 when it comes to any type of game on the traditional platforms. So our physics simulation doesn't suffer from this amount of error. It's not noticeable. We work very hard that the frame in itself is packed to its fullest and organized in such a way that does not have an impact on gameplay. It's very crucial for that. Now, if you go lower, if you go to a model where we have to run at 30 hertz, any kind of that just becomes more difficult, and any kind of error accentuates the flaws that you have when you run at a lower frame rate. So that was one of the challenges. We spent quite some time on making sure that the frames were more even.
Doom Eternal has a lot of improvements in general, I would say, to how smoothly the engine runs, and so that's one of the reasons that it was not as much of an issue this time around. But we also spent a significant amount of time shoring up the areas. There's always going to be spots that only have problems on the Switch, because only the Switch maybe drops below 30 FPS ever. And so we tend to find bugs that weren't present on the other platforms for that reason. And so we took a lot of time to fix those little issues, whether it's making a platform thicker so you don't fall through it, or changing the way an elevator functions to make sure that there's no weird blipping around on the elevator, things like that. We took a lot of time to make sure all that was working correctly.
That's really interesting. So you're basically solving issues that normally wouldn't crop up due to the lower performance profile. That's cool.
Yeah, there's a lot of content changes that you have to when you make these type of versions. You have to take content and layouts into account. You can't some of the data that you make for one platform if you target different frame rate, you do have to make some content changes in some aspects. And it's not just, I'm going to lower my textures. It does go into goes into collision detection, and goes into LODs, it goes into geo detail, and how fast does a projectile fly, those type of things.
Yep. And we actually use more levels of detail in our meshes than the other platforms. So whereas they would use more like 3, we would use as many as 5 levels of detail. And we don't actually render that worst looking level of detail anywhere you'd ever see it. It's one of the tricks we employ is that for an object that's very far from the camera, and might even be occluded and not visible, if it managed to slip through the cracks of our occlusion culling, but it's very small and very far away, we can have that be half as many triangles as the other platforms. So we spend less of our frame time processing this thing that doesn't contribute. And so in fact, once you get low, and generally speaking, when you run the game at lower resolution, the artifacts from the compressed smaller LODs are less noticeable. And so you can bring them in closer to the camera before you see any visual issues. But for things that are very close to the camera, we use the same highest level of mesh detail as the other platforms. And so
wow.
If you have an enemy right in front of your face, you're seeing that same mesh that would be present on.
Is the distance modified at which it pops over to the highest quality LOD?
You see the highest quality as best as we can. It's the transition into the further distance that gets modified.
Right.
So when it transitions to LOD 1, 2, 3, whatever, those distances get modified, and then for different objects we use different distances. A lot of things that affect that are contour or shapes that you want to retain. Many times geometric detail. You don't see things within a mesh, but if you see the silhouette of something changing, that's very easy to be noticed. Let's say you have a building with a spire on it or something. If that spire would disappear, you immediately see that pop, right? So we work very hard at making sure that the general silhouette of the object is retained, and that's very important because then you can hide a lot of internal detail slowly degrading. Your eye is very good at fooling you that there's actually more there than there actually is, which is very neat. We take advantage of that quite nicely.
Yeah, I mean, and this makes a lot of sense since the maximum rendering resolution that could ever hit is 1280 by 720, and it's often under that. But I mean, that goes back to just like the old days. You play like Super Mario 64 at 240p on the N64, and there's LOD transitions. You almost couldn't see them, but as soon as you loaded it up on an emulator in high resolution, it was extremely obvious when it would pop between the different LOD levels. And it's the same thing here, where you're right, at a distance, enemies kind of crawling around, it's very difficult to almost impossible to pick that out. So it does feel seamless. And that makes a lot of sense, I guess, given the scale of some of the arenas. Which makes me wonder, was there any map or like battle arenas specifically that you guys remember where you're just like, oh man, that one was a tough one to optimize?
There was one in particular that in Sam's base. There's you
gave it away.
Yeah.
Everybody's gonna look for that one now.
Yeah.
Naughty.
That one, tremendous improvements were made to that scene. It's shocking how much faster it runs now compared to where it started. But that was a particular challenge because tons of glass, tons of transparency.
Oh, yeah.
So large parts of the scene are visible that don't really contribute to the gameplay. I mean, it's cool to see, but when you're in the middle of a combat and there's an enemy in your face, you don't have time to look through that glass, but you're paying for it. And so we a lot of steps were taken, and it helped us a lot with this to improve the performance in that scene. In fact, Billy made some changes himself that were helpful there. So yeah, that was a challenge. There were other scenes that were challenging too, for various different reasons. Some of the scenes with lots of animated world geometry, the geocache that Billy was alluding to, is very expensive to process on the Switch, and so there are some cases where we use much more aggressive compression on the data stream to make that cheaper, and also in some cases we just took certain parts of it that were animated and made them not animated. But since nobody noticed, we know we made the right choice. There's little spots where, at low resolution, it's not as noticeable that you have like a little bit of ambient environmental animation in the distance. At 4K, it's very noticeable if that were to suddenly be turned off.
I would admit I didn't really catch that at all. Like it, on the surface, it really felt like all the geocache animations were fully there. So
we took strides to make sure we wanted to preserve the important ones. That was the goal, is to make sure that the very visible and key, especially during the cutscenes, those had to all be preserved. So, because a lot of the very big payoff moments in the game are these, complex world geometry animations.
When we make these, when we look at these parts of the game, it's always about like, what are we trying to achieve here? Is this a combat space? What is the story of the scene? Is there storytelling in the environment that needs to convey the ferocity of the combat, for example, or is it just something that was added because we could, so we try to make pragmatic choices that maximize the feeling that we wanted to achieve for each of the scenes. That's very important because we want the exact experience that you may feel on one platform to manifest itself also on this platform. So we spent a lot of time on that, looking at what was important for the scene. Is the user going to focus on that? What will they care about? Okay, will they care about the Mancubus, blasting their flamethrower or whatnot, and the fireballs of the imp in this particular scene? So we focused on that. Or like, oh, this is a vista shot. We really need to make that spectacular because that's this visual storytelling that the player needs to experience before they go into the next scene. It's always about playing the game as a player, and because as a developer you're so close to the project that I see only flaws. I look at our games, I'm like, oh my god, what's happening here? How's nobody seeing this? And it takes you actually have to take it back and be like, play it as a consumer, because when you're making something, any artist or programmer will tell you this, that all you see are the mistakes. That's why there's a famous quote where people say art is abandoned, never finished, right? It's the same thing here. I would say that we take a step back, we play the title, we get the feel, and really be super critical. If I was purchasing this, what is the thing that I'm feeling right now? Is this the same feeling that we wanted as developers? So that's the approach we take.
Some of the intelligent cuts we made, here's an example of one of the things that we thought was important to maintain and not change, is the wound system, the way the bore and wound on the enemies appears. We really felt that it was critical to maintain that look and feel exactly the way it is on the other platforms. So we made cuts where it made the most sense, but we also tried to preserve what was critical to the experience.
Cool. Did you guys have to do any tweaking to the sound system, like in terms of the sound data or anything in there, Were you able to kind of bring that over pretty well, or like how did that impact the development?
It is, in some ways, this is one of the areas in which IDTech, being a next-gen engine, complicated matters. That they have shifted towards a more aggressive audio compression format for this title, which meant that we couldn't get free money of doing that ourselves to save memory. But so no, we did extensively tune the audio in collaboration with our audio team. Countless hours spent tweaking sounds here and there. Combining multiple sounds when it made sense. Again, it's all about making the cuts where it has the least impact, and we're very pleased with how it turned out. The audio is, I think, one of our best efforts in terms of a switch port. So we spent a lot of time tuning it just so, and it's also very important to do that because the audio is a big chunk of our total CPU time, and so it's very important that we not exceed our budget for that, because the hardware can do a lot of that for us, but once we run out of our hardware budget, anything else that we do with audio is coming out of our budget for doing gameplay and everything else. So it's critical that we keep that as tight as we can.
And one thing to note on audio, first of all, I mean, a big thing of Doom is the audio. It's the music. It's the effects that play. It's a huge part of the game that needs to be retained, that needs to play well, and the mind is really, and the brain is really good at picking up when there's something wrong with audio. It's one of those things that, like, if audio's off, boom, you immediately catch that. Some visual glitches we're not so good at sometimes catching. We can do a lot more tricks there, but audio has to be right. So and because of that, because of the nature of wanting to make the music play and the effects all play out, we spend some time on that, and I think it turned out really, really good. I think the audio work was amazing from Travis and our sound engineers and us on the id side.
Yeah, I tend to agree. It sounds really good. So just as sort of a theoretical thing, I guess. Just your own thoughts. If you were designing a new Switch, what features would you guys want to see the most from a developer's perspective, where you're just like, okay, this would be awesome to have in a portable hybrid kind of unit?
That's a good question. I mean, I'm so focused on the work we're doing right now, I don't have time to think about that very often. But obviously, the more power they can throw at it, the better.
Yes.
From our perspective, although maybe we wouldn't be quite as in demand if it were easy to port games to the Switch. But no, I think we'd all love to see what can be done with a handheld device. What I feel like we in recent years we've made such strides in technology in terms of miniaturization. We have 7 nanometer process, 5 nanometer, 3 nanometers coming, and that really allows you to do a lot with a handheld device, because that's the limiting factor is your volume, your surface area, and the battery life. And so by having these incredibly compact chips that are starting to come out these days, that's really what made the Switch possible in the first place. If you think about it, even though by today's standards it doesn't seem as small a factor, but at the time that size process was very small, and so previously, prior to the Switch, you wouldn't have been able to have that experience in your hand. So I think going forward we're going to see more of that. I can't predict it, but I think there's going to be more in that direction of putting more power in the hands of the players, and probably with it higher resolution and who knows what else.
Thinking of resolution, I've kind of wondered about this. So obviously, Doom Eternal uses the excellent TAA solution that IDTech 7 offers. But two things there. One, I guess for future, I think something like machine learning could be really interesting in the handheld space in terms of lowering the native pixel count. But also, did you guys look at all at changing the method of AA? Because TAA does clean up the edges really nicely in a lot of the artifacts, but when your resolution is quite low, it can also give it this sort of very smeary look. Did you guys ever consider having an option to disable that? I mean, I know that IDTech really relies heavily on a lot of temporal passes, but still, I'd be curious to see what that might look like.
The TSAA is one of the contributing factors why it looks so good.
Yeah.
It really evens out the image quality significantly. I can't talk about what we're gonna do on that front because that would be giving away what we're doing next. There's a lot. I mean, we like to push the envelope, right? That the goal is to make it awesome everywhere and keep pushing. We keep trying to push the best. So we're always working on anti-aliasing solutions. When it comes to lower end resolutions, obviously ML would work. It just takes, we did this project, we didn't have the time to really focus on that part. Maybe in the future we'll be able to look at that.
And that probably wouldn't really be feasible on the Switch itself, of course. But
But Billy's point is excellent, though. We've talked about and experimented with turning off TSSAA multiple times. I think every project someone asks the question, well, can we turn it off? And the answer is you can't. You really can't.
Don't want to.
I think, one example would be, let's say you're running in handheld and you're in a scene where, due to the particle effects, we're running at the minimum resolution of the handheld. That resolution is so low that if it were not for temporal supersample aliasing, the image quality would be just completely lost. And the reason is that we're able to pull in detail from previous frames to add additional detail. We're doing the super sampling to get a 720p image that has more detail than was present in this frame. And so, you could say, oh, you're running at 360p, but it looks way better than any game could have run at that resolution on a device from like the PS1 days or something.
because you're accumulating all that data from previous frames, right?
And we go through a lot of trouble to make sure that we have good data to accumulate in all cases, not just there's a tremendous amount of work that goes into making sure that we have that data available and that it's good data. So it's really, and in fact, the other thing worth pointing out is that some of the effects in the game don't look right without temporal anti-aliasing, because we're essentially taking something that would maybe be a hard edge, and by using jitter and multiple frames of sampling, we're taking it and giving it a soft edge. So if it weren't, the shadows is a good example of that. I think there would be visible artifacts in the shadows without that anti-aliasing technique. But that allows us to have a soft border to that shadow that would be much more expensive.
Well, that's good to get that out there, because that is something a lot of people have asked me about as well. It's like, hey, if you pause the game on a frame change, of course, when you don't have that data, you get a super sharp looking image. Like, why can't we have that? And well, there we go.
Well, you get lots of aliasing jitter in movement. You don't want that. It looks nice in a still image for screenshots. That's fantastic, but you get lots and lots of noise in the image that
noise. And it sounds like, the artists originally, they designed with that in mind. So it sounds like it would kind of just make some of the effects look wrong. So that makes sense. That's good. That's cool.
Again, it has to do with the overall feel and look of the game fluid. And we do a lot of our frame can switch, especially on the PC, on the consoles. They can vary quite a bit, but our resolution scaling and TSAA and so on allows us to keep the image quality at a certain really stable kind of look, even though there's a lot of stuff going on, pushing and pulling in lots of different areas, to make sure that all the work that needs to get done gets done in a way that it fits with the hardware that we have. So in some frames, something may take longer here, but we then take that work away and we give that work somewhere else, and then allows us to even out the image quality. It's extremely crucial to be able to do that. Again, it's all about the feel of the title, and that includes the visual look and what the player perceives. And TSAA, the resolution scaling, the adaptive tick, and then all the other systems that we have are all to try to cohesively put this frame together in a way that it gives this cohesive experience.
Cool. So, obviously you guys have been doing these Switch ports for a while now. If you look back over the years from Doom 2016 up through Eternal, are there any things specifically where you guys are just like really proud of an accomplishment, like some feature or technical accomplishment along the way?
Well, it's hard not to point to Doom Eternal, since it is the best looking game and best performing game we've done on the Switch. So, and it's also, just an awesome game. But beyond that, because it really, I mean, this is an advanced engine with some very complex visual elements to it, and so the bar was much higher. The challenge of getting some of these features to work on the Switch was much greater, and so we had to really pull out all the stops to get this to fit, and so that has to stand out as my the thing I look at, but I still look back at Wolfenstein 2 about managing to get 5 million triangles to run at 30 frames a second was something that I was shocked at that we were able to achieve at the time. It seemed unheard of for a device running on a battery to do that. So that was impressive too. But no, this takes the cake for sure.
That's awesome. And I guess the last thing, to just wrap up then is, you guys managed to ship this game on the Switch during the whole pandemic situation. How has it been for you guys as a studio transitioning to sort of a work from home, approach? And is there anything you could take away from that, going forward?
I think it's for every development studio, it's a challenge. I think it's a challenge for collaboration. It's a challenge for just the sheer amount of data that you have to transfer between team members on a daily basis. For example, we might send multiple builds to QA to test in one day, and it might take me 3 hours to upload it and take them an hour to download it. And that really kills our iteration time and our productivity when collaborating like that. So there have definitely been a lot of challenges, but I think like every other studio, we've all learned how to deal with them, and we managed to ride that out fairly well. So hopefully it won't be too much longer.
Yeah, hopefully not.
I think we adapted really, really well to the challenges of the current pandemic. I think it's rough on everyone. It's a difficult situation. It's mostly logistics. We value the time we spent on over those meeting calls like we're doing here. The human contact is very important for development. The collaboration and finding ways to do that remotely with a large group of people. I mean, we're shipping 2 DLCs, and I would say the DLCs are some of the best work, if not the best work we've done so far. And we were able to do that while not being together. So that shows our ability to adapt. It shows the willingness to make great content, and we'll get through this. I think we're learning from this experience. So when hopefully at some point this will be over, we're even better than we were before. We're learning a lot of things that work well in this situation versus they weren't working so well when we're all together. And it's a really eye-opening experience, but it shows that if you stay persistent, you work hard in the sense of collaborating, and you have a common goal, you can achieve great things. So everyone just stay in there. We're going to make it through this.
Absolutely.
I kind of feel like that's a great place to end it, actually. Very good words to hear. So gentlemen, we've talked about a lot of things today, and hopefully the people watching have enjoyed this as well. But I really want to thank you guys for joining us here today to discuss this, because it's certainly something I was really looking forward to.
Thanks for having us, John.
Thanks for having us, John.
Of course. And if you guys at home enjoy this video, as always, like, subscribe, ring the notification bell, all that good stuff. Come find us on Twitter. Go find these guys on Twitter, and definitely check out Doom Eternal on the Switch. It's a really cool conversion, and I have another video up on the site showing that. So until next time, this is John signing off.
A gaming icon evolved. Logitech's renowned G502 mouse joins the ranks of the world's most advanced gaming mice with the release of the G502 Lightspeed. Featuring ultra-fast wireless connectivity and reliability, with performance trusted in competition by esports pros. Featuring the next generation Hero 25K sensor and PowerPlay compatibility, this is the ultimate rendition of the celebrated G502 mouse.